free session and anyone can participate. So next is about the curiosity quiz that we are normally conducting on Monday as well as Friday at 9 p.m. So next quiz will be on tomorrow. So kindly do participate. It will be about the JEE paper 2 mock. So about that also, if you have any doubts, you can just use the live chat box, or else you can just comment in this video. We will be happy to help you. So not much delay, let's start today's session. So Rusa.
Yes, sir, we can start.
Audible?
Yes, sir.
Okay, sir, shall we start then?
Yes, sir.
Okay,
Good evening,
sir.
students. Thank you, sir. We are going to discuss this JEE paper 2 session 1. And let me start by question number 1. The question is, the equation of the plane passing through the point of intersection of the point of intersection of planes r dot I plus 2j minus k is equal to 3 and r dot 2I minus j plus 3k is equal to 2. And the required plane which we have to find, it is parallel to the line, the equation of line given here, that is x minus 1 upon is equal to y minus 2 upon is equal to z minus 3 upon 1. This is our question. Let me repeat this again. The equation of the plane passing through the point of intersection of planes r dot I plus 2j minus k is equal to 3 and r dot 2y minus j plus 3k is equal to 2. And it has to be parallel to the line x minus 1 upon 1 is equal to y minus 2 upon 2 is equal to z minus 3 upon 1. So whenever we have to write the equation of a plane which is passing through the point of intersection of two planes, we write it as p1 plus lambda p2 is equal to 0. Right? This is family of planes. So let me call this equation as P1 and that one as P2. We can take this as P1 and the other one as P2 as well. There is no restriction over here. So R times 2I minus j plus 3k plus lambda times R dot I plus 2j minus k will be equal to 2 plus 3 lambda. All right. So let's take the coefficient of I. R dot 2 plus lambda times I plus 2 lambda minus 1 times j plus 3 minus lambda k. This is equal to 2 plus 3 lambda. Now, according to the question, this plane have to be parallel to this line, right? So when we take the dot product of 1, 2, 1 with 2 plus lambda, 2 lambda minus 1 and 3 minus lambda, this will be equal to 0, right? Because 2 plus lambda, 2 lambda minus 1, 3 minus lambda, these are the direction ratios of the normal of the plane. So if the line is parallel to this plane, it means the normal of the plane perpendicular to that. So 1 into 2 plus lambda is 2 into 2 lambda minus 1 plus 1 into 3 minus lambda should be equal to 0. So let's do this calculation. These two will get cancelled. These two will get cancelled, and that is equal to 0. So we got 4 lambda plus 3 is equal to 0. That will give us the lambda value as minus 3. Alright. So when we take this lambda value and put it in this equation which we have found, we will get r dot 2 plus lambda. So 2 minus 3 by 4. That is I. Plus 2 lambda minus 1 we have. So minus 6 by 4 minus 1 j plus K value. K value is 3 minus lambda. That's 3 minus will become plus 3 by 3. That is K. The entire thing is equal to 2 plus 3 lambda. 2 plus 3 into minus 3 by 4. So when you simplify this, it will come as 5 upon 4 I. This will become minus 10 by 4 J, and it will become 15 by 4 K. This is equal to minus 1 by 3. So let's cancel the 4 from the denominator of all this. And then we can take minus common, because whenever we write the equation of a thing, we actually try to keep this constant value positive. So when we do that, it will become, write the answer here with the right thing. So it will be clear for you guys. It will become R dot minus 5I plus 10J minus 15K is equal to 1. That is the answer. I hope this is clear to all of you. I'm going to give you some time so that you can copy before I get the next problem. Children, please copy fast. If there is any question regarding this, question number 1, put it in the chat box. We will keep on posting stuff like that, which is good for your exam. So please do subscribe and like our channel. So whenever we post something new, you will receive a notification. It will be good for your exam. That's good. We do have a JEE mock test coming on 23rd. So you should register on the link which is given in the live chat that we will be sharing. And the link will also be shared in the description. Click on the join and register yourself on 23rd. There is a JEE mock test to attend that. Okay, let's go with the question number 2. Let f and g are functions from R to R. Okay, these are the two functions. Voice is breaking. We have good internet connection. Try to join it back again. Function defined by and fx is equal to x minus 7. Gx is given as greatest integer function of 7 plus sin x. I will slow down just in case. Okay. So this is Gx, where this box represents greatest integer function. And number of points we have to find. Number of points in 0 to pi. Fog of x plus graph of x is not continuous. Is my voice better than before? Okay, so let's try to find fog of x. Fog is nothing but f of gx. So when we calculate this, f of gx will become f of 7 plus sin x inside this box, greatest integer function. So 7 plus sin x minus 7. Okay. Using the property of greatest integer function, this can be written as 7 plus greatest integer function of sin x minus 7. So basically, it has become greatest integer function of sin x. Let's calculate graph g of fx. That is g of x minus 7. So that is 7 plus sin x minus 7. 7 plus greatest integer function of sin x minus 7. Okay. So add fog and graph. If we add it, we have sin x greatest integer function plus 7 plus sine of x minus 7. Now think about this problem. 7 is a constant value. It has nothing to do with the continuity and discontinuity of the function. Right? So our main thing is greatest integer function of sin x and greatest integer function of sine x minus 7. So please copy this and then I'll take it in the next phase and I'll discuss the point of discontinuity. All right. So to discuss the continuity and discontinuity of this, let's draw the graph of sin x. This is how sin x function will do. Zero, pi by 2, pi. At this point, at pi by 2, function will break. Why? Because here to here, the value of sin x is going from 0 to 1. So greatest integer function will be 0. At this particular point, the greatest integer function will be 1 because the value will be 1. After that, again, we are going down from 1 to 0. So the greatest integer function will be 0. So this is one point of discontinuity. That is for sin x. Sin x greatest integer function will be discontinuous. At x is equal to pi by 2. And let's discuss sin x minus 7. So x goes from 0 to pi. X minus 7 will go from pi minus 7 to minus 7. Minus 7 is a value which is less than minus 2 pi. Minus 2 pi means minus 6.2. This is 0, pi, 2 pi. This. So minus 7 is somewhere here. And then x minus 7. X minus pi minus 7 is 3.14 minus 7, which is minus 3.86 approximately, which is somewhere here. Is the minus 5. In between this, at this point, as you can see, there is a point of discontinuity. Because from here to here, the value is in between 0 to 1. So at this point, it is becoming as 1. So that's another point of discontinuity. when you go down from here, from 1 to 0, the value of greatest integer function is going to be 0. At this point, it is 0. And from here, it will become -1 because we are going from 0 to -1, right? So greatest integer function will become -1. So at this point, again, it will break. So when the value is, when x minus 7 is equal to minus 3 pi by 2, and excuse me for a second. Is equal to minus 3 pi by 2, then there is a point of discontinuity. All right. And when x minus 7 is equal to minus 2 pi, then there is another point of discontinuity. These 2 points of discontinuity are coming because of sine x minus 7. Okay. So we have 3 points of discontinuity. Total, there are 3 points of discontinuity. Okay. Please copy this. This diagram is important. Copy that. I'll wait a minute for you guys to answer. We'll definitely work on that. Thank you for your advice. We will definitely try to bring that. Okay, let's take question number 3. M and N are non-negative integers such that for x belonging to minus pi by 2 to pi by 2, tan x plus sin x is equal to m, and tan x minus sin x is m. Then the possible ordered pair of m and n is, and in the option it is given as 2, 1, 3, 4, like this. So options are 2, 1, 3, 4. We need to calculate possible ordered pair. Okay, let's think about this problem. If we add these two equations, because both of them are linear equation in tan and sine, let's add them. So when we add them, it comes as 2 tan x is equal to m plus n, and tan x is equal to m plus n divided by 2. Now, they have told that both m and n are non-negative integers. It means both of them are positive. So if both of them are positive, m plus n by 2 will be positive. If tan x is positive, it means x belongs to first quadrant, because our angle x is given from minus pi by 2 to pi by 2. So obviously we can't have the value of x going from minus pi by 2 to 0 because in fourth quadrant tan will be negative. But we have m plus n by 2 as positive, so we can't have that. It means x is in first quadrant 0 to pi by 2. So from here, if I write sine theta, sine x, then subtract, and we will have 2 sine x is equal to m minus n. Sine x is equal to m minus n by 2, which should be positive because tan x is also positive. If it is positive, then m should be greater than n. So 3, 4 option will be removed because here m is equal to 3 and n is equal to 4. So let's take m is equal to 2 and n is equal to 1. So sin x will come as 2 minus 1 by 2, which is 1 by 2. If sin x is 1 by 2, it means x is equal to pi by 6, 30-degree angle. So what is tan x? It should be equal to 1 by root 3. But according to this, tan x will become 3 by 2. Is it possible? It is obviously not possible for sin x to be equal to 1 by 2 at the same time tan x to be equal to 3 by 2. So we'll have no such order pair. Okay, copy that. Okay, I hope all of you understood this problem. Let's take the next one then. Let fx is defined as x plus 4 whole square minus 4 for all values of x greater than or equal to minus 2. This is how fx is defined. Then x such that fx is equal to f inverse x. Okay, find such x. We have f inverse x is equal to fx. Right? So we have f inverse x is equal to x. So this will make it x is equal to fx. So we can say x plus 4 whole square minus 4, that will become equal to x. X square plus 8x plus 16, from here it is only calculation, is x. X square plus 7x plus 16 minus 4 is 12, 0. And we'll have x plus 3 of x plus 4 is equal to 0. So two values are satisfying this. X is equal to minus 3 and x is equal to minus 4. Both of these values are satisfying the condition which was given for x is greater than or equal to minus 4. Okay, so we have these two values which will satisfy fx is equal to f inverse x. If you want to verify this, you can put the value of x as -4 over here, and then you'll get -4 cross 4 whole square is equal to, that is, this will give you 0 minus 4. So -4 is equal to same value, fx is equal to this. This was a small problem. I think there are some questions like this in NCERT also, which you guys must have seen. Copy this. I'll take question number 5. Okay, see, when we calculate inverse of a function, suppose y is equal to, you have x squared. So when you calculate the inverse, you do x is equal to root y, right? So you try to bring the function in terms of y, then you change that into x, right? So fx is equal to x have to be done. F of x is also given as f inverse x. So when you take this, f of fx will be equal to x, right? F of x, you can put this value here. Then you can try from there. Let's take question number 5, which is a big problem. I hope it is clear now. Z be a complex number. Theta is given as tan inverse of imaginary part of Z upon real part of Z. Okay, modulus of it. Be an acute angle. Of course, it will be an acute angle if we have taken modulus. Argument of Z is theta minus pi. Okay. Real part of Z is equal to real part of 1 minus 2i power minus 3. And imaginary part of Z is equal to imaginary part of 1 minus 2i power minus 3. These are the details given in the problem. Then find 125 times imaginary part of Z plus 2i upon Z bar. This is what you have to calculate. Okay. See, start from here. Argument of a complex number Z is given as theta minus pi. It means the complex number is in third quadrant. When you have the complex number in third quadrant going like this, then total value, total angle minus pi will give you this acute angle theta, right? So assume Z is equal to minus x minus iy, where x is positive and y is positive. So minus x and minus iy will be a complex number in third quadrant. Okay. Real part of Z and real part of 1 minus 2i. So let's calculate 1 minus 2i power minus 3 in the beginning. It will be 1 upon 1 minus 2i power 3. which can be written as 1 plus 2i power 3 divided by 1 minus 2i into 1 plus 2i whole power 3. I'm trying to rationalize the denominator. This is a minus b of a plus b, which will become a square minus b square. But 1 minus 4i square can be written as 1 plus 4 because the value of I square is minus 1. So 5 power 3. So this will become 1 plus, expand this, 2i power 3, that is 8i cube, plus 3 times 1 into 2i of 1 plus 2i divided by 5 cube is 125. So this is 1. 8 cube is equal to 8 into I cube, that is minus 8i, plus 3 into 2, 6i, plus 12i square is equal to 125. 12i square is minus 12. So 1 minus 12 is minus 11 upon 125. This is the real part. And we have 2i upon 125 with a negative sign as imaginary part. So according to this, real part of this is equal to real part of that. So x is equal to 11 by 125. And y will be equal to 2 upon 125. Because imaginary part of z is modulus of imaginary part of 1 minus 2i power minus 3. We need to calculate imaginary part of z plus 2i upon z bar. So first of all, let's calculate 1 by z bar. Shall I go to the next page? Or I'll wait a second so that you guys can copy this. Now, let's try to calculate 2i upon z bar. What was z? Z was minus x minus iy. What will be z bar? It is minus x plus iy. 1 by z bar, 1 by minus x plus iy. Rationalize this. Minus x plus iy of minus x minus iy, then we'll have to multiply with this. Divided by minus x whole square minus iy whole square, which will become x square plus y square, and from here minus x minus iy. Okay. So 2i upon z bar. This will become 2i times minus x minus iy divided by, or this is y square, minus 2xi minus 2i square y divided by x square plus y square, minus 2xi plus 2y divided by x square plus y square. This is 2i upon z bar. What do we need to calculate? Z plus 2i upon z bar. So z is minus x minus iy, and then plus minus 2xi plus 2y upon x square plus y square. You are already aware of the values which is given here as x and y. Okay. They have to ask, we have to calculate only the imaginary part. So we can remove this integral, this real part which we have. So minus I by minus 2x upon x square plus y square. Let's remove I. This is the imaginary part. Okay, mod of it. So how much is minus y? Minus y will become, because y value has come as minus 2 upon 125. So this is 2 upon 125. Minus minus plus 2 into 11 upon 125 divided by x square, that is 121 upon 125 square plus 4 upon 125 square. Calculation part, you guys can do it. 22 upon 125 divided by 125 upon 125 square. So one of that will get cancelled. Okay. So 2 plus 22 into 125 divided by 125. This will be the value. Multiply and get the answer. Copy that, please. These were the lengthy problem which was given in this year paper. 3 of them. This was one of them. Then you had other question where you had to find greatest integer, the greatest integer function problem. That was also a little lengthy problem. Apart from these problems, the rest of the problem are pretty easy, straightforward. Okay. So let's take the next problem. Let A is a 3 by 3 matrix, Aij, where determinant of A is not equal to 0. B is another matrix, Bij, which is 3 power I minus j of Aij. Okay. For all values of I and j equal to 1, 2, 3. So some options are given, which is to find the relation between determinant of A and determinant of B. So let's try this. Assume a matrix A as A11, A12, A13, then A21, A22, A23, A31, A32, and A33. All right. This is matrix A. Take another matrix B. But the element of matrix B, see, if I take A11, then I is 1, J is 1. 3 power 0 will become 1. So this is simply A11. But if I is 1 and J is 2, then it is 1 minus 2. That is 3 power minus 1, which is A12 upon 3. Similarly, A13 upon 9, 1 minus 3 will become minus 2. So 2, 1, this is 3, 2, 1, 2, 2, and 2, 3 is A23 upon 3. Then you can take this as 9A31, because 3 minus 1 is 2, and 3 square will become 9. A32 will become 3A32, and this is A33. So what we do is try to expand determinant A. A11 of A22 minus A33 minus A12 of A21 into A33 minus, excuse me, this will be multiplied minus, we have A23 into A32, A21 into A32, and then A22 into A31, plus A13 of A21 into A32 minus A31 into A22. This is the determinant of A. Let's try to calculate determinant of B, and we'll try our best to find out the roots. A11 of A22 into A33 minus multiplication of these two. 3 and this 3 will get cancelled, so that is A23 of A32. Simple. Minus A12 upon 3. When you multiply these two, 3 will be outside. So 3 of A21, A33 minus 9 into 1 by 3 will again give 3. Okay. Plus A13 upon 9 if we take, that will become 9 times A21 of A32 minus 9 times A31 of A22. So you can take 3 common from this one and 3 will get cancelled. 9 common from this group and it will get cancelled. Now the remaining quantity which we have, it is equal to this. This one is equal to the second one of that, and third one is equal to third part of it. So basically, determinant of A has come out equal to determinant of B. Is that clear? Copy this. See, in this paper, first few problems were a little bit difficult. Okay, but after that, it was easy. So what I suggest to the students is, when you find that a question is difficult, skip that. All right, skip that problem. Solve the remaining which you think that it is a little bit easier. Once you do that, and when you still have time, then come back and try attempt those problems. Do not get stuck in a difficult problem and waste your time. It happens with most of the students. It can happen to the best of us. That is why you guys need to practice few papers before you are going to write the exam, so that this time management thing will come. Okay, let's take question number 7. Next problem. Let A be a 3 by 3 symmetric matrix. It be a symmetric matrix with integral entities. Let me come back to you and answer your question. If the sum of all the diagonal element of A square is 2, then the total number of such matrices A is equal to. Okay, coming to your question. See, theory part at the last moment is never advisable. Okay, what you should do is you should solve as many different question paper as possible, because when you're solving the question, theory part will be revised through the problem, and not only that, you can also become faster by solving more and more problems. So it improves the speed, and then you will have, because what happens is there are a lot of things in the theory which is not that much required in the problem solving. It is good for understanding the concept, which is very good if you are starting in the beginning. But towards the end of this, right before the exam, we advise not to study anything extra. Whatever you have studied, just try to solve question on it or check out some question paper and try to practice problems. Even if you want to, suppose after this also, if you want to practice some question, practice some theory part, go through NCERT. That is more than enough. Memorize the formula and check out the problems of NCERT, because that book will not take that much time, and it covers the theory pretty well. All right. Okay, let's take this. Assume a matrix which is symmetric. So let's take A, B, C, then this will be taken as B. Let's take this as D, E, this will be taken as C, E, and F. All right. Welcome. So when we take this, square it, multiply. In the problem, we just have to talk about the diagonal entries of A square. So when we multiply, let me just write only the diagonal entry, nothing else. So multiply this. It will become A square plus B square plus C square. I'm going to skip this term, that term, because that is useless for our problem. Coming to this, BDE will be multiplied with BDE. So that will become B square plus D square plus E square. Now, I hope it is clear to you guys now that without doing anything, we can write C square plus E square plus F square. Okay. So when we add all these three, we'll have A square plus B square plus C square plus B square plus D square plus E square plus C square plus E square plus F square. This is the sum of all the diagonal element of A square. So check this out. A square is appearing once, D square is appearing once, and F square is appearing once. So A square plus D square plus F square, will keep it separately, plus other terms, B square, C square, E square are appearing twice. According to the question, the sum is equal to 2. Now this will happen in two ways. How? If B square plus C square plus E square is equal to 1, then A square plus D square plus F square have to be 0. And if this is equal to 1, that is possible in three ways. Either B, C, or E. One of them should be equal to 1. Rest, all the values should be equal to 0. So three ways. Second case which we can make out here is A square plus D square plus F square is equal to 2, and B square plus C square plus E square will become 0. So all of these B, C, E will be 0, and 2 out of these 3 A, D, E should be equal to 1. So that will give you 3C2. That's another 3 ways. So how many total number of ways we got? 3 plus 3, that is 6. So we can have 6 such different matrices. I hope this is clear. All right, very well. Let me repeat. We have a JEE mock test coming on 23rd, which is on Saturday, I believe. Please register. The link will be given in this live chat, and it is also given in the description. Practice the paper. It will be good for your exam. And students, like and subscribe the channel for the more of, because we keep on giving good contents, and you'll have a notification whenever we come up with something good content. Okay, we can take one more problem. If 20C1 square plus 20C2 square, 2 times this, 3 times 20C3 square, dot, 20 times 20C20 square. This is equal to K. Then find K into 20 factorial square divided by 40 factorial. So basically you need to calculate K. Once you calculate K, you can find out this value. All right, so let's take this. How much is K? K is 20C1 square, 2 into 20 C2 square, 19 into 20C19 square, plus 20 into 20C20 square. Let's write it like this. And I want to write the same thing again, but in a little different manner. How? I want to start with 19 here. 20C19. So I should have 19. Then 20th, I'll write it here with 20 into 20C20 square. Then start with 1 into 20C1 square. Okay. Then this will be 18 into 20C2 square. 20C18 square. 20C19 is equal to 20C1. 20C18 is equal to 20C2. 20C1 is 20C19. And 20C0 can be written as 20 into 20C0. 20C20 is 20C0. So let's add these two values. K plus K, 2K is equal to 1 plus 19, that is 20 times 20C1 square, 20C2 square. It is going up to 20C20 square which is coming from here, and then 20C0 square is also there. So this 2 will cancel this time, it is 10 times. So you will have k is equal to 10 times 20C0 square, that is 20C0 into 20C20. 20C1 square, 20C1 into 20C19. So on, 20C20 is 20C0 into 20C20. All right. This is coefficient of x power 20 in the product of 1 plus x power 20 of 1 plus x power 20. 10 times coefficient of x power 20 in 1 plus x power 40, which is 10 times 40C20. This is k value. So k into 20 factorial whole square divided by 40 factorial is equal to 10 into 40 factorial divided by 20 factorial into 20 factorial multiplied with 20 factorial whole square divided by 40 factorial is equal to 10. Okay. So the value of k will become 10. Is that clear? Children, I wish you all the very best for your upcoming exam which is most probably going to happen on 25th, I think. Not 100% sure because dates are not cleared yet, but it will be around 25th. So prepare well and good luck. I'll wind up the session with this.